All right, I think we should be going. Let me know who's on and who can see this, or when you get on. I'll give it a few minutes for people to hop on, especially since I'm getting going late today. So just go ahead and speak up in the Slack chat when you hop on. Let me know that you're there, and we'll get going in just a few minutes. Yeah, better late than never. Better than last Tuesday, right? Yeah. All right, I'm starting to see people hop on. So here's your other challenge, and you guys can do this here at the start of class if you did this or not. Part of our homework from last class was to take a look at one of these the documentation around one of these built-in objects, and it could be one of the ones you've already worked with before or a different one that you're not familiar with, and try and find a method or a property on it that was interesting that we haven't already used, and say something about it in the Slack channel. So if you've taken the opportunity to do that, you've taken a look at some of the documentation somewhere online for one of these objects and you found a cool property or method on it, feel free to post that in Slack now, just whatever that is. And if you want to give a summary of what that method or property is on it, then go ahead and do that. If you haven't taken the opportunity to do that yet, I really encourage you to do that. Please dive into documentation for some of this. I can post a link to some of the ESLint, wow, I'm looking at the wrong section of my screen. I can post a link to some of the MDN documentation on some of these objects so that you can choose some of that and dig into it as well. But I really, really encourage you to do that, both just to get used to looking for new stuff and also to begin to get used to reading the documentation that is out there on the language, because it's going to be a challenge at first to read all of the terminology used, but it'll be worth it. And I'll give you an example of that right now. So let's choose string here, and we'll just go ahead. Ooh, the error object provides information when an error occurs. Yeah, that's a good one. Let's choose a string and let's go look up some documentation on it. And I'm going to look up a string here. This is using, of course, the tool I like to use, which is this devdocs.io page. And I see first, it's a global object as a constructor for a sequence of characters. We'll come back to what a constructor is today, start touching on that. But if I just keep scrolling, this is why I was saying the documentation can be a challenge if you haven't looked at it before. So it takes a little bit of practice learning to read this stuff and also learning to skip the stuff that isn't that important. So this is both documentation for how to use this constructor to create objects, but down here we'll also see documentation about this object if we get far enough down. So just keep going, and then, oh, there we go. A string has some properties, which it says the only one it has here is a prototype. All right. But then it also has some methods. And we'll touch on that again, but this is a perfectly fine review. A method is just a function attached to an object in some way. And so in this case, some of the methods are from char code, which actually means character. It's just sort of short for character. And it's saying it returns a string created using the specified sequence of Unicode values. Yeah, I don't really know what that means. From code point, returns a string created by using the specified sequence of code points. Also, maybe I don't know what it means, but what else do we have? Oh, here we go. A string instance. Okay. So an object that's a string based off a string, that has a length. Yeah, we've already used that, right? That's something we're pretty comfortable with. What else do we have here? Here's a useful one. Let's take a look at this for a second. Includes. And I'm going to click into that. So what does it say? The includes method determines whether one string may be found within another string, returning true or false as appropriate. That seems really useful. Something that I might want to use again in the future, so I'm going to try and remember it. And they're even going to have an example here. All right, we've created a string. It's a sentence, and then a string of a word, and it checks sentence.includes word. Nice, and then it gives you some information about what it does. So we could even try that out, right? Like, let's give that a try and see what happens. I should come up with a new string. What's a good string, a good saying to have? I don't know. If anyone has any great ideas, feel free to speak up. Let's just come up with something. Var. Maybe something fun and silly. What do I have? Wow, it's funny. I'm stuck on coming up with a fun, witty little string here. Sorry, I can't hear you. The light is on. All right, yeah. That seems fine. So we got a little string here. Now we can try out this includes method. And I think if I go back and look at the documentation, what did it say? Its parameters are it takes a string to be searched for within this string, and then it takes an optional position parameter. Well, I don't care about that. So let's just try this. Pass in a string. Let's say light. And sure enough, there we go. Gives me back true. So, but if I say, let's try dark. Nope, that's not in there. And there might be some of this that, isn't obvious at first. Because if I do ear, you're thinking, well, there's no ear anywhere in here, except it does exist as part of here. And it doesn't know to parse this only across words. So that's true, right? So you may end up with matches that you didn't expect on something like that. But there we go. We just learned about a nice, useful new method on strings that we didn't know about before. So I really want to encourage everyone to go choose one of these objects. As I said, it can be string, number, Boolean, object, function, array, date, regex. That may be one that's something you don't need to look at yet, or even air, and read up a little bit on it and say something to everybody. Let us know what you're sort of learning about, because there's no way that you're ever going to be able to learn everything that you need to know about a programming language in class. So you're going to have to learn to go dig this stuff up yourself and parse through it. And if you're having a hard time reading the documentation, if you want to spend some class time showing you how to read that documentation, how to walk through it, let me know, speak up. I will be more than happy to help do a session in class of how to read some of this different documentation. All right. Moving on from that, let's just review the other two concepts that I think were critical that we sort of learned for the first time in the last class. And we already touched this one, method. A method is just a function attached to an object. So there's nothing too fancy about that. It's a function on an object. And then this is one of the most important concepts that you're going to encounter in JavaScript. It's a real challenge to fully understand how it works. It's very similar to other programming languages, but a little different as well. But you can think of it for the most part, until we get into some of the complexities, that this just refers to the object that you're part of. So this is usually used within a method on objects in order to have access to other stuff on that object, to read something out. So if we were to create an object that was, we've done our person before. We'll create our very simple person here. Oops, I didn't do an equals. We're creating a name. And they're going to have a greeting. And the greeting is just a function, but I want it to be able to say their name inside of the greeting. And I want it to be flexible enough that if the name changes, we can still use it. So for this function, I'm going to use this object literal notation, or the object literal notation, because I find it easy. And then you can do this dot name. And we've got a person. And on our, let me do that again, move it up a little bit. On our person, we also have a greeting, which is a function. And if we invoke that, I'll say, hello, my name is John. And if we change the name, we got Jane, and we do the greeting, we get the. So this is a way to refer to properties on your object within methods on your object. It's probably the most common usage. There are other places where you would use it, but that's really the most important aspect. If you want to refer to something on the object, you can use this. All right, so today for new concepts, I want to talk just a little bit, and this isn't a new concept, but I want to emphasize it because we'll have some homework around it, and then next class I'm going to introduce a concept that builds on it. So I want to make sure that everyone sort of understands that this is allowed, which is just functions can call functions. And then we're going to talk more about objects for the rest of the class. We're going to talk about another way to access properties on objects, how to iterate over the properties on them, and a couple other ways to create objects. So first things first, let's talk about, I didn't even finish my notes here, right? So functions can call other functions, and this is what's known as function composition. And this is really important to understand and to get practice with, because this will allow you to build complex programs. If all of your functions don't invoke other functions, it's going to be really hard to build anything complex at all. So let's build an example of this. Let's say I want to build a what is the Pythagorean theorem, right? A squared plus b squared equals c squared, I believe. So that's how you can find any angle on a right triangle. So let's create some functions that are going to allow us to compute the hypotenuse, the length of the hypotenuse of a right triangle. And I'll put some notes here. A squared plus b squared equals c squared. For anyone who's not familiar with that. So an example of that is 3 times 3 plus 4 times 4 equals 5 times 5. Or if we want to reduce that, it's 9 plus 16 equals 25. That's just an example of the Pythagorean theorem and how you can solve for any of the angles if you know the other two. But let's write something that's going to allow us to solve for that, right? So we'll create solve for, and I'm sure I'm going to spell this wrong, but that's fine. Let me go Google it real fast. Hypotenuse. Hypotenuse. All right, there we go. So we're going to pass in A and B. All right, now what I want to be able to do is square those. And yes, there is a square function built into JavaScript, but for the sake of showing you how to compose functions, I'm going to say, oh man, I really want to be able to do that, but I don't want to have to write all of that in here because it's complex. So, well, actually, hold on. I want to solve for C, right? So I have to figure out this equation. Let me see. I need to take the square root of a squared plus b squared. Okay, so I'm going to have to use a built-in function because square root isn't easy to do. But let's do squared, and let's create a function for that. Let's just call it square number, and it's going to take in a number and just return the square of it. And this seems really silly because it's a very basic bit of code, but this could get much more complex. So then in the solve for hypotenuse, what I need to do is a square equals square number for A. And you get b squared equals square number of b. So I've got those two. And then what I need is the square root, which I happen to know is built into the math function. So I can go ahead and write it out like this. And there's nothing particularly fancy going on here. So if we have, let's call this a few times. Let's print out console.log. Let's print out what we get from invoking this. I'm going to cheat here because I'm lazy and copy it so I can invoke it a few different times with some different values. So we know 3 and 4, we should get back 5. Off the top of my head, I don't know of any others that have even numbers, but I'm sure some exist. So let's just try 4 and 5 and 5 and 6, and let's see what we get back. So let's try this out, see what we get. You get 5, 6.4, and 7.8. And again, this is a very, very basic version of what I'm talking about. But the idea is you can invoke a function inside of another function. And by doing so, it allows you to break your problems down into very small bits of code that can be reused in other places. It creates this compositional nature where you can really build up to something more complex. Now, next class, we're going to take this same concept and build on it by introducing the notion that you can even call the same function from within itself. And that's what concept known as recursion. We'll talk about that. Or if we fly through the material for the rest of today, maybe we'll get to talking about recursion a little today. Let me know if there's any questions on that. That should be pretty straightforward, but let me know if there's any questions on just even the concept, or speak up if you weren't aware that you could call a function inside of another function, if that's surprising to you. So the next thing we're going to build on here, or the next new concept, pretty much everything else that we'll be talking about is related to objects. that was one that wasn't really tied into objects very directly. But now we're going to be discussing objects for the rest of the class. So the first concept that we have here is the concept of bracket notation. We already have one way to access properties on an object. Does anybody remember what the name of our current approach to get properties off of an object is? If we want to see the value of a property? Let me scroll up that stuff up. Yeah, I can come back and touch on working with functions inside of other functions again, happily. We'll be able to come back and touch on that again later in class. I'll try and come up with another example off the top of my head that we can leverage. Yeah, there we go. Dot notation, right? That's our existing model for accessing a property in an object. So if I go back in and I open up a read eval print loop for Node, we can create an object. Let's do something a little more fun this time. So we're going to make, instead of just a random person, let's create, say, a video game character. So let's create our player object, and we're going to give him some properties. Name. What should our name of our video game character be? I don't know. It's got to be some silly name that just sounds like gruff or something, like a video game. Yeah, that's right. Getting all D&D up in here. We'll build on this. Like someone with two first names, it just sounds silly. All right. And because it's a video game character, let's give them some hit points. They haven't been damaged yet. They have 100 hit points. What else is our video game character going to have? They're also going to have, let's give them a strength. He's pretty strong, but as a result of being strong, because video games want to be balanced, pretty slow, right? Not a very fast character. And then, yeah, let's create some abilities. So he's got, what does he have? I don't know. He's got shield, some sort of ability, and maybe he has like a power jump. And a charged attack or something. Yeah, just throwing some fun stuff on there. So we've got our player. And our existing model to get stuff off of it is very easy. We just do .name. Works just fine. It's particularly good at talking to narwhals. Wow, that's cool. So there's another syntax, though, and that's what we're talking about now, is there's what's known as bracket notation. So bracket notation is just another way of reading the properties of an object. And when you use bracket notation, the expression inside of brackets, and in this case it's square brackets, is evaluated, and the value from that is used as the key. When using bracket notation, the property name must ultimately be evaluated to a string. So I've got some examples here where we've got a very simple scoop for ice cream. It's got a flavor of mint chocolate chip. And this is how you use bracket notation. We've got square brackets and the direct string of flavor in there, and that would print out mint chocolate chip. But you can also make it an expression that must be evaluated. There's nothing wrong with that. And in fact, that's usually when you would be using it. So we've got like property here, and now we can pass that into this square bracket notation, and that will ultimately evaluate to flavor. which is mint chocolate chip. So if we go back to our player here, we could do player dot or bracket notation, hit points, and we'll get back the value. And that's just the same as doing player.hp. So the question here is, why do we have two different syntaxes? What's the value in having this bracket notation syntax versus the dot notation? And one of the main reasons you have that is because if you're using a variable name, you can't use var hit points equals HP. I can do player hit points using this variable, and it will evaluate that variable, see that, oh, this is actually the string HP, and then get the HP property off of the player. But I can't do player.hitpoints because that's attempting to reference a property named hit points. It doesn't know without the bracket notation to evaluate that. So that's going to be undefined. So where does this come in handy? If you're just accessing one property and you already know what it is, not particularly useful to be able to do bracket notation. But a really good example of where you would use it is, let's say you want to iterate over all of the properties in an object. Turns out, talking about useful methods on some of these built-in objects, we've got a really useful one called .keys, which is on any object. So if we went over here and we did our keys, let me see here. Oh, wait. I think I did this wrong. Just a moment. I need to pass the player in. The .keys is on the object. So I've stated that wrong. It's not actually on the player object. It's on the object. So if I access the built-in object and I pass my player in, it will actually give me back an array of all of the keys of my object. So those just match my key values for it, which is awesome. And so now I can iterate over this object. In the example I have here, it's iterating over this album. So I'll go ahead and copy all of this over and we'll put it in and then we'll talk about it some more. But this bit of code, we're creating this album with a name, artist, year, and copies sold, properties on it. Then we're getting the keys, which is an array. And then we're using our standard while loop. So there's nothing particularly surprising about this. We are doing something a little different here where we're using the pop method of keys instead of something else. That's how we're changing our condition for our while loop. And if somebody wants to look that up and explain what pop does on an array, I don't think we've talked about that, but that would be a good example for somebody to look up after class. So then they can say, what does the pop method do? I'll give you a little bit of a hint as it pulls the last item off the array, mutating the array as a result. But this allows us to print out all of these different properties of our object in a nice readable way. And you wouldn't have been able to do this without using bracket notation. Dot notation won't let you, if you don't know the exact property name that you want to access ahead of time when you're writing the code, then you have to use bracket notation. Another example might be, let's say you don't know, you have possible properties and you're not sure which one you want to actually read the value of. You've got a bit of conditional logic that changes what you want to read. Then that would be another case where being able to use bracket notation would be really useful. So let me see if I can come up with a good example of that right now. Let's say, yeah, I'll try and build on some of that a little bit, but we'll keep working with bracket notation. This is going to be a critical thing to get used to. So that's one to really get comfortable with as well, is working with this concept of bracket notation. That's the other major way that you access stuff on objects, and it's very, very useful to be able to use bracket notation. Go ahead and let me know again if you have any questions on that. We'll come back to it if people have any questions. We can talk about how it works a little bit more, or just using it in other places where you might use it. But for now, let's step down into just other ways to create objects. So far we have learned one way to create objects. Does anybody remember what the method of creating objects is that we've used so far? It has a very sort of specific name. If you look at the Mozilla Developer Network, they'll use a different name for it, which we'll see in just a second, but we've been consistently referring to it one way so far. All right, I don't know if anybody remembers or not, but the approach we've used are object literal syntax. It's sometimes also called object initializer. And the reason it's called object initializer is because that's a term used for similar behavior in other languages. But object literal syntax, that's exactly what we did for our player here. Or do we still have a person? We don't. So if we created a person, this is just object literal syntax. So you're creating this literal object right there within those curly braces. But today we're going to take a look at a couple different ways, other ways to create objects and work with them. So the first one that we're going to talk about, and we'll talk a little bit about the pros and cons of these different approaches as well. The first one that we're going to discuss is using a factory function. So far we've been creating these one-off objects, right? But what if we want to create the same type of object over and over? That's one of the big values of working in an object-oriented language, is you're able to create objects that are similar. They've got similar properties and similar behavior over and over again. You know, an object, the most common approach to this, or one of the common approaches, is what's known as a factory function. And it really is pretty much like what the name implies, right? It's very literal. It's like a manufacturing factory. It takes in some parts and produces a new car, computer, whatever the manufacturing factory produces. A factory function just takes in some values and returns a new object based on those values. And there's really nothing magic about it. It's just a special name for a type of function. So we've been doing this bit where we're creating our objects right here. But if we instead, and I'll show you an example of one here, if we instead created a function, and in this case, it's useful if you give it a name that is going to make sense. So, oh, it's called a car factory. I expect that I'm going to get a car back out of this. Then you can pass in some of the properties, or what will be properties of your object: make, model, year. That's what we've been doing before. And here, we're just using object literal syntax to return a new object with those properties on it. So it's really, really easy. It's just building on top of what we've already done. It's combining functions and object literal syntax to be able to create multiple objects of the same type. And that way we could call it over and over. So again, if we took this, and let's write a little program building on this, right? Let's just, and then I'll go show another example too. So if we've got our car factory, I'm going to create an array of cars. And I'm just going to go ahead and push some new cars into this one at a time. So car factory. And if anybody has a car that they want to push into our array, go ahead and speak up. The make, model, year. We'll get that car pushed in as well as we're working on this. But let's just add some items to it. So let's do a make. This is a Mazda. This is going to be my car pretty much. And it's a Mazda 3, 2007. All right, there we go. We'll do a cars.push. Again, because I want to do this multiple times, you're going to see me get really lazy here. I'm just going to cut and paste this a few times to get some things in here. Let's see. All right. Hyundai Tucson 2013. Sounds good. What else do we have? Let's do, who's got a higher end car? Somebody has, I need to choose a manufacturer I can actually spell. Or wait, Toyota's coming out with a cool new car again this year, right? Isn't it? It's the, what car is it that they're bringing back? The Supra, right? Yeah. That's got a lot of hype. What else do we have? All right, a Ford Escape. I like it. Let's see. What's another car? Let's go with something classic. An older Corvette. I wish I could remember the first year of the Corvettes, but I think in the 70s, that's when they were doing the Stingrays. Those were cool cars, right? Yeah, those were cool. So now we can just do whatever we want with all of these cars, but what we did was we created a whole bunch of things that all have the exact same information on them, right? So, oh, okay, well, it's easy. Let's create this for loop, working with them for var index equals 0, right? Index is less than cars.length. Index plus plus. And now we can get, let's create a local variable. This is just going to make it easier for us to work with this so we don't have to do cars index over and over. We can just do it at the start of the for loop. And then, maybe we print some stuff out. Console.log. I drive a car.make. Oh, wait. Usually you would say it like year or something, right? Like, and then make and model. Okay, let's see if this works. Probably have a bug in my code. Yeah, seems like it works. So that's an example of using a factory function. And what it gives us is the ability to create objects over and over of the same type. And now what we could say is, oh, maybe let's make this even easier. Wait a minute. This seems like it could just go up into a method on the car, maybe. I don't know, we could. And so we go up into our factory function here and we say, I don't know, brag about your car. And that's just a function that's going to return I'm going to take the string here. We'll need to change it a little bit. How should I change this to make it actually work inside of my object literal so that it'll work correctly for each one of these cars? Because there's something wrong with this return statement right now. That's going to make it not work correctly. I'll wait for that, and I'll just make the change down here at the same time where we'll change this and say car.brag about car. But once we move this up into this method, we've got a problem right now. And if you're not sure, go ahead and say you're not sure. I'd love to see people saying that. I just want to see any interaction. So let me know if you're like, I'm not sure what's going on there. I'm not sure what would be wrong with it. I can go ahead and try to run it, and we'll see what happens. Hopefully it'll be clear. I don't know. Oh, something's wrong here. Oh, you know what? It's totally going to work. Wow. It's working for a very weird reason. And that's because every time this function gets called, the car object exists. If I got rid of this because I don't actually care about this anymore, it's interesting. It was totally going to work because a car variable exists. So if I get rid of that, now we're going to blow up. And that's okay. Well, it doesn't have the brag about car. Well, I need to fix that. So in this case, I'll do cars of index. All right, let's see if that fixed my problem. Sure enough, it fixed that problem, but I've got another problem. When I try to call this, it says car is not defined. And that's because up in here, since it's now a method, if I want to refer to myself, I don't want to use car. I want to change that to be this. That way, it knows it's talking about itself each time. Yep. And that's the type of thing that you'd probably do a lot too. So, you know, you'll decide, oh, I need to move this around, and it should exist here. Now, to me, though, something about this code doesn't seem right. And it's not the car wouldn't really brag about itself, right? Oh, that's a good question. Could I have said carfactory.year? No, I could not. And that gets into some complex stuff about JavaScript. You can attach properties to functions. So if you want to look at this, right, if we hide the details, carfactory is just a function that takes some values and returns a new object. So this is just an object literal. And the way that you can refer to anything inside of an object literal is by using this inside of the method. If we tried carfactory.year, which we could try, and let's see what happens. Again, I totally encourage you, try code, see what happens. It says undefined each time. And that may not be obvious at first as to why, but maybe it will be if I add another little bit of code here that says console.log the value of year on car factory is So let's see what that tells us. The value of year on car factory is undefined, and that's what it's reading out every time, is car factory.year. Wait a minute. It actually just read that right off the method, the function. I'm going to do something here that I don't encourage you to do yet. This isn't something that you should be doing in your code, but let me just test something. What happens if I put a year property on my car factory? Let's make it 2000, because that's not used in any of our other stuff. Now what happens with our code? Oh, I can just add properties to a function. Again, not something you really need to be working with right now, but that's what it was trying to read, and it didn't exist. So it needs to be this to refer to itself. So building on this, what do people think? Do you feel like it makes sense for a car to brag about itself, to say what type of car it is? I mean, unless, and this will date me, unless you're like Kit from Knight Rider, your car probably isn't talking and telling you what type of car it is or saying that, right? So if it's not the car that should be saying what it is, what do we think should be saying what type of car it is? Like what type of object or entity would say, oh, I drive, a 2007 Mazda 3. And it doesn't exist in the code yet. So I'm not asking you a question of like what's already in the code. The question is like, what would you describe? What do you think something would be that would try and brag about a car or talk about it? There we go. What about a car owner, right? Geez, that'd be really nice. So let me check here. I'm not certain. I think in my next example, oh, nice. I've got a person factory here. So this is an example of a person factory. It's almost just like our car factory, except I wrote it a little bit different syntax-wise, just so that you can get comfortable with different types of syntax. So I'm going to take that and put it into my code up here. I also want to be able to have a person factory. And this is going to take a name and an age. It's just going to create this nice little empty person object here, add those properties to it, and then add a say hi method to my person as well. Let me fix some of my indentation and spacing issues. All right. So I also have a way to create a person. Cool. I'm going to sort of shove this code down a little bit for the time being. So let's just call it Jared. This is me, I don't know. A person factory. No. We can lie here. We're gonna say 21. Oh, you wouldn't. Oh man, that's vicious. I wouldn't brag about a Mazda. Brutal. All right. So let's check something here. Let me do Jared.say hi. All right. I created a person here. Oh, I have a problem. Oh, I need to call person factory, not person. Tried to call the wrong thing. See what happens. Hi, my name is Jared. I'm 21 years old. All right. It's working. Yeah, let's make this more honest. He's 21 years old. Which is cool. But we also wanted this to be, let's make this more specific. It's more than just a person. Instead of a person, let's create a car owner factory or a vehicle owner factory. And so what they're going to take in is a little more. They're going to take in a name, who they are. They don't care about their age, but they do care what vehicle they drive. So I'm going to make some changes to this. They don't have an age, but they do have a vehicle. And that's going to be something that we want to pass in. Now let's change our message here too. So first off, I'm just going to simplify this. Let's do this at first, right? And let's practice this. So we don't have a person factory, but we're going to have a vehicle owner factory. Pass the next argument we want is a vehicle. Okay, well, we don't have a vehicle yet. So we're missing something at this point in the code. So I'm going to get rid of this for loop. I'm going to get rid of this iterative thing, and we're just going to create one vehicle, one car. In this case, it'll just be 2007 Mazda 3. Let's create it right before we create me. So we're getting back this vehicle. And I'm going to pass that in as my second argument to my vehicle owner factory. Let me comment out the rest of these. For now, let's just see if the code works. The car factory bit should work. That was already working. The vehicle owner factory, well, maybe I have a bug in here. We'll find out. Okay, so it does work. But now what I want to do is take the message about the car, and I'm going to take this and move it into down here instead. But we've got a couple things we need to do to make that change. The first one is we move it down here, we delete it from our car factory because it doesn't actually belong on a car, as we were saying. It's an attribute of a person who owns one. And the next bit is, if I tried to run this just right now, it should run, but it's going to tell me undefined, undefined, undefined. And that's because this refers to the person or the vehicle owner, and the vehicle owner doesn't have a year property. But what I need to do is get the year of the car, and the vehicle owner does have a vehicle property. So now I can do this dot vehicle dot year and this dot vehicle dot make. And I'll scroll over here. This dot vehicle dot model. That's because those are all properties of this other object that is now part of the person or the vehicle owner object. And there we go. Now we can print out this nice little message about what I drive. I sort of built it up together, right? And now we've got something that's actually really powerful. Now we can do all sorts of different combinations of cars and people and create them over and over with a lot of flexibility. And what we're using here is a couple different concepts. We're using the concept of composition. That's what we've talked about. One of our fundamental building blocks of programming here is, instead of putting all of these properties of the vehicle on the person directly, we created a separate vehicle object which contains the properties of the vehicle, and then we just attach that vehicle to the person so that we've composed those two objects together to do something new. We're also leveraging some encapsulation or some hiding where you don't have to know all the details of how this object that you're getting back is created. And in this case, it doesn't make a big difference, but we could hide a whole bunch of logic in here if we wanted to. We could have some logic that says, like, this person.name. Maybe we don't always want it to be that. We want to say, we're going to create a variable internally called I don't know, fake name. And originally it's an empty string. And then we're going to have some logic that says if name is equal to, oh, let's do it this way. We just learned about a new property of strings today. So let's build some more stuff up. If name includes Jared, fake name equals, what's the fake name here going to be? Let's use my gaming handle, hyperdeficit. And then I'll say otherwise, fake name equals name. And now here, I'll put my fake name in instead of my real name. And if we run that, we should see, all right, instead of Jared, we get back something different, right? And the beautiful part is all of that logic is hidden inside of this object factory, so we don't have to expose that. We can hide that, and if somebody wants to create objects of this type, they just get to use that logic automatically. Gotta wake computer back up. There we go. Are there any questions on using an object factory like this to create objects, or any of this object composition that we're working with today? This is a much more complex example than what we've done so far. So we're pulling in a lot of different aspects of what we've learned in code to build something. Again, feel free to speak up at all. Let me know. Or just let me know if it really clicked and you think you understand what I'm talking about. Say something there too. The more feedback, the better here. In the meantime, I'm going to keep moving on, and we'll talk about the other approach to creating objects that I wanted to cover today, and that's what's known as the new keyword, or a constructor function. So this one's definitely different than the other approaches, because this won't use an object literal syntax at all. Another way to create objects in JavaScript and in a lot of other programming languages, this is really the only way to create objects, is using the new keyword, where you call a special type of function which is known as a constructor. And really the simplest way to do this, the simplest example of this, is to just call the object constructor using the new keyword. This example here, I'll show you, and we'll just inline this or bring up the read eval print loop to show this. This bit of code where we created a scoop this way would be the equivalent of saying var scoop2 equals, and then you create an empty object, scoop2 dot flavor equals chocolate. Those are really the equivalent of each other. Doing that set of curly braces, this here is actually just shorthand for saying new object. It's just a nice little syntactic sugar, but it's a lot easier to pick up at first. But this is using this new keyword. An object is a function that we're calling, and using the new keyword to call it does something special. And you know object is just a function because we've actually used, well, we don't know it's just a function, but it's a little interesting that it's just a function because we've actually used this already, right? We've called the keys method on an object. That's very intriguing because if we looked at the type of object, it tells us that it's just a function. Again, type of is lying there right now because really the only types that we have are the primitives and objects. So a function is an object. Whereas if we did type of scoop, it's going to tell us it's an object. That lets us know that this object thing is a function, but that function has some of its own properties on it, like keys that give us some behavior. The key to this idea of using a object constructor function is the new keyword. If you invoke a function using the new keyword, you get back an object. That's what gets returned. So let's do an example. Let's go back to our person here. And let's talk about how you would actually write something like this. And this is where I was saying this is different because for the first time, we're not going to, there's a few interesting things about this function. So I'm going to put this over here in the scratch pad. And if there's anything that you think is interesting or different or poses a question to you about how this function is written, feel free to speak up. I'd love to see some comments about what's strange about this function or what's different about it than most of the functions that we've written so far. In the meantime, I'll go ahead and start. Let's create another person. I don't know. Let's make it, let's just go with Micah. And I'm going to create this one using this constructor function. So I'm going to pass a name in. I'm going to pass an age in. Good age, 32. And we can call the method on it. Hopefully somebody sees some weird stuff about this, the way that it's written, maybe, that triggers you to say, wait a minute, what's going on with that versus what we've done elsewhere. Any thoughts on that? Well, let me highlight a couple things that are different about this. If you did this, the first is that we're using this directly inside of our function. This isn't in, we're using it inside of this method, yes, but in this function, we're doing this dot name. What in the world does this refer to inside of our function here? Well, that has special meaning when you call a function using the new keyword. That ends up meaning, oh, the function that I'm going to give back, that's what I'm referring to. And the other thing you might notice here is no return statement. We're not actually returning something from this function, at least not if we called it directly. Now we could call this function directly as well. So I'm going to take this bit of code and put it into the read eval print loop so we can play with it a little more interactively. So I could call person, but it returns undefined. It actually returns nothing, and that's because we didn't have a return value. And that's it is intended to be called using that new keyword. what it returns when you use the new keyword is a new object. And it's a new object, different object every time. So if I did person2 equals new person, remember our lesson last time about object uniqueness, that just because they have the same values doesn't mean they're the same. So if I did person equals person2, they are not the same object because we got a new one back each time that we use this constructor. Let me scroll down here. And then any properties that you want to add on the object that's created from the constructor function, use the this keyword at the top level. So we did this dot name, this dot age, this dot say hi, and just assigned it to. Any questions on using the new keyword to create function constructors or creating function constructors? Another thing that's very common here, and you'll notice I use this, a convention that's pretty universal, is that if it is intended to be a constructor function, it starts with an uppercase. That's just sort of that bit of convention that says this is not a normal function, this is a constructor function. Questions or thoughts on that? Clicked. I'm not sure. Being said there, but all right. So we'll be coming back and talking more about working with constructor functions. And we'll talk more. I don't know if we'll use object factories a lot more in class, but we'll definitely be using constructor functions because that's a very common way to create objects. And it does have some nice properties that we'll be able to leverage. And I'll give you a little bit of a preview of one of those right now, which is that we don't actually have to. So there's something sort of interesting here. If I were to go in and look at the person that I got back from this code, and I've got these say hi functions. So if I did person.sayHi, well, that's a function. If I do person2.sayHi, that's also a function. And we can see if those functions point to the same thing. So if I do person.sayHi equals person2.sayHi, that's false. So even though those functions would do the same thing and give the same result, they're not actually pointing at the same function. They're two different functions. And an example of that, or to highlight that, is if we changed one of those functions. Here we have Jane, or the first one. And if we did person2.sayHi, all right, the same thing. Now if I change it, person.sayHi equals function console.log So now I do person.sayHi. We get just hello, I'm Jane. But if we do person2.sayHi, we get the old message. So as a little bit of a preview of one of the benefits of these sort of constructor functions is we can actually make this method the same across all of these. And the way we're going to do that, don't worry about all the details of the syntax today. We'll really talk about this a lot next time. Is we're going to take it off of this direct object that gets returned, and we're going to put it on the prototype object, which is actually farther down the chain. So I'm going to take this logic and pull it right out of here. And instead, I'm going to say person.prototype.sayHi equals this function right here. And now what's going to happen with this little bit of code, or if I have this. So let me grab all of this, go back into here, kill my read-eval print loop so I can redefine this easily, and create all of this. And if I create Jane, if I create John, and we can check this on each one of these. Okay, we've got these two. But if I did Jane.sayHi equals John.sayHi, now it's true. And so they're actually into the same function at this point in time. Instead of two copies of that same function, we have one copy of that function, but both of these objects are able to call it and refer to it. And that gets into the concept of inheritance and how objects get built up from other objects. Again, we won't dive too deep into that today. That's really going to be the focus of the next class, most likely, is starting to talk about object inheritance and how some of that works. But that's some of the benefits that we can get when we use a constructor function method to create our objects, as opposed to creating them using the object literal syntax. Yeah, that's an interesting point, right? If you're familiar with some other programming languages, sometimes this bit of code wouldn't have been able to be written outside of my constructor. So this is something that is a little bit unique to JavaScript, to do a little bit with what I was saying earlier about the way this works. It's a good question. Does prototype make a copy? No, prototype isn't actually making a copy. The prototype, again, we'll dig into it in the next class in detail, but if you want to think of it as every object has a prototype of some kind, and that goes all the way down until you get to a prototype of null. But every object has a prototype, and that prototype is itself an object, and multiple objects can have the same point to the same object for their prototype. So that's really what's going on, is essentially there's another object underneath this person constructor, and whenever we create a person from the person constructor, that person says, oh, my prototype is this other object down here. So if we looked at Jane.prototype, is this the right? Oh no, I need to do it this other way. Jane. This is a little weird. Here we see her proto is, oh, this person object with say hi. Oh, that's where say hi is at. And we could, again, as I said, you can keep going down. Prototype of that, oh, it's just the basic object. And the prototype of that is null, so you can't go down anymore. And if we tried, we'll see that that doesn't work because null doesn't have a prototype. So we threw an error. So we'll dig into that more, but really there's a use for all of these different ways to create objects. And there's at least 2 more methods of creating objects that I'm aware of in JavaScript. One of them we may talk about a little bit, which is object.create. And the other one, which is using what's known as a class, we're not really going to dig into, at least in this intro course, because that's a newer syntax and it's a little too similar to other programming languages, and I want to keep the concepts separate for the time being. I don't want to relate them too closely. All right, so those are the new topics I wanted to make sure that we covered today. Want everybody, again, please go look up some of these objects that are built in and just say something, find something about one of them and post it in the chat so that we can all get a little more informed about what's going on with these objects. If you find the documentation too confusing to read, too hard to understand, then please say that in chat as well so that we can go over how to read some of this documentation. It does take a little bit of practice to get used to reading it because it's not as simple as standard book, right? It's got a very technical syntax that can be a challenge. Now let's cycle back for a second. There were some continuing questions about functions, calling functions. So let me come up with another good example here. Let's build on what we had in this class a little bit. Let me see where it is here. What do we have? All right, this is a good example. Let's take this album, and we're going to build on this. So let's create an album object. But I also want it to have a couple other properties. Let's give it a price. How much does this cost? This is going to cost like $9.95. Yeah, let's just give it a price. That sounds good. And let's say, again, we'll go back to, you'll see me using these same examples over and over, and that's an attempt to have you sort of build up some practice using things that are similar so that each time you're not having to learn a whole new domain, but also learn the new concepts and how to apply them. So let's turn this into one of those examples where we want to, I'm going to create a function that lets somebody check out. I don't know. Right? They're checking out from the store. And what we're going to pass in here to check out is our shopping cart. So I expect this checkout function to get a shopping cart of some kind. And that's actually going to be an array. So down here, I'm going to make one. I'm going to create a cart array. And then I'm going to put the this album in it, for example. And maybe I'm going to create something else. What else am I going to pick up here? Oh, I'm also picking up like the record store or the music store. I'm going to pick up a poster. I don't know. Let's get a poster of Dark Side of the Moon. And it's Pink Floyd. And this thing also has a price. Poster is, I don't know, $14.70. And while I'm there, I also want to I'm going to pick up a soda. And this is a Pepsi, because Coke is not good. and it's going to have a price of $1.50. I'm going to give this one a category, or I'm going to give it a property. Is food true? So now let's say I want to check out, and I've got this shopping cart. I'm going to push some other stuff in there. I'm going to put some other stuff in my shopping cart. I'm going to put this poster in there. And then I'm going to put this soda in there. And you'll notice where I've declared this checkout function. I'm going to move it down here just for the sake of making it easier to read, but it could have been up there. And then when I want to check out, what I'm going to want to do is compute my actual price of everything. So if I get a shopping cart, I'm going to say my total is nothing right now. And then let's iterate over this for index equals 0. Index is less than shopping cart dot length index plus plus. I want to get an item out of it, so I'll get whatever is at that position out. And then what I want to do is I want to compute the price of this item. But you know what's really annoying? It'd be really annoying to have to put all of that logic in here, because it makes this function very complicated, right? Oh, my function is super complicated, and this checkout doesn't need to know how to compute the price. So what if instead I take all of that compute price logic and I move it up here? And what is my logic? Well, let's say I have 2 tax rates, or I don't have any tax on food. So the key here is if item dot is food. So if that's true, then I just want to return item dot price. Otherwise, I'm going to return item dot price plus or times whatever the tax rate is, 8.75%. And what I can do here is I can just total increases by the compute the price of my item for each item. And then in the end, I can, I don't know, print this, console.log. This is another example of composing something using different functions. We've got this compute price, and what's really nice now is, boom, I just hid those details of it. And I'm just looking at the checkout. Let me see if this works. There's probably a bug because that's a lot of code to write without a bug. Oops. A lot of code to write without a bug. Sure enough, something's not working. Oh, I never call it. There we go. So I guess I need to check out, right? So let me do check out with my cart. Now let's see if it works. Oh, nice. So that was that's really useful. We were able to compose something using this compute price. Now let's say, oh man, I also want I want to print out the information about each item as well. So it'd be nice to be able to print that out. Well, I could write another function, right? Print item details. And maybe that does console.log. I don't know. It might just be the name. Maybe that's the only thing that's consistent. Oh, I don't need that syntax, right? I'm not inside of a template literal. Well, now each item, so print item details, passing in my item. Now I get a nice little inventory of my stuff. Oh, everything has a price too, right? Okay, maybe I do want this to be a little more complex. I want to print the name of it and say before tax price. I'll get rid of the price bit there. I think that's obvious. Oh man, I really want, this is gonna be a little weird syntax wise. I need a $sign in front of this because I want it to say, you know, how much it does dollar wise. Oh, there we go. So that's another example. I think probably maybe a little more complex, a little better example of using this sort of function composition builds up, right? We've got a function here that does some logic, and then we've created these other functions that we can use as well. And one of the nice things that I think you'll notice here is if I was to take all of this logic and instead of calling these functions, let me get rid of that. Let me pull all of this in some way, right? I'm going to just comment this line out for the time being. Total plus equals this, otherwise total plus equals item dot price. I mean, I could totally have written this that way. But it's a lot harder if I'm reading this function right now to know what it's actually trying to do. I can't really read it in plain English. There's not a nice, easy way for me to read it and say, okay, what is this doing? That's trying to print something. I don't know. And then I've got some logic here. Whereas if we go back to what we had, this, barring a little bit of extra stuff up here at the start, almost reads like a sentence. And we could even make this nicer instead of this ugly syntax at some point. But this says, for this item, print the details of the item and then add the computed price to the total. I can almost read that. Whereas when I had all of those details sitting right there inside of that one function, there's way too much for me to read it. It's way too complicated. I hope that's another good example of calling functions inside of functions. And when you might want to use that sort of functional composition. That's one of your primary building blocks to creating reusable code, is learning how to use function composition in this way. So it's definitely something for you to get some practice with and to get very comfortable doing. All right, I think that's all I have for today. That went longer than I expected, actually. So if anybody has any questions, let me know. Please speak up about the homework. If anybody's been watching, you know, there have been some people working through it. I even had bugs in some of the answers or my tests so that people couldn't pass the homework. That was a mistake. But I'm really glad that somebody was, you know, going through it and found those with me and was able to work through it. If anybody's stuck on any of it, also speak up. so that we can help you work through that, or make sure that we cover that material again in a way that's hopefully easier to work with or understand. Next class, we'll be talking more about objects, but now we're going to be talking about the concept of object prototypes and sort of object inheritance, or what that looks like in JavaScript. So that gets into a very deep object-oriented programming principle and concept. And I'll see you next class. Oh, I'm also going to post the survey again, so you can take that again and give me feedback. I appreciate those of you who did take it last time, and just it was really useful. I definitely am taking that advice, and we'll be modifying the way we work on some things going forward.